So we're going to start this YouTube video off right talking about James Charles and the fact that I, Mr. Taylor, have now lost 3 million subscribers in one day. And yes, I know the video has started. So, with this ice diagram, okay, let's do a quick refresher, okay? Because Sanaya admittedly might not know.
There we go.
Okay, shout out you on the YouTube video. Ooh, you YouTube famous now. Ha,
Wait,
she already
did you
was.
hit the start button?
Now, let's go.
Oh, okay.
The video is live.
Oh man.
Crap that. So, with this, let's say that we have this reaction. Let's say we have AlCl3, which is aqueous, and it's going to break down into aluminum, which is a solid, and chlorine, which is a gas. Okay, to balance this, we got a 3, a 2, and a 2. Okay? When you set up the ice diagram, again, one of the things that I said I like doing is putting a line through the arrow so you know, hey, reactants over here, products over here. So, let's pop to the philosopher in the room, philosopher V. Which one of these don't count? Aluminum doesn't count, that is correct. Can't have a concentration if it's a solid. It's not dissolving, it's just sitting there. So it cannot have a concentration. So that is out. Again, initial, change, equilibrium. So again, you are going to use this if you have the beginning stuff. Sometimes I'm going to give you the numbers, that's the equilibrium values, that's safe to use. The whole like, hey, it's 0.3, plug it in. Hey, it's 0.4, plug it in. You guys will turn your homework in a few seconds. Initial though, things change at the beginning. So, do you guys want this reaction to go forward or backwards? Let's start there. Want to do backwards one? That cool?
Sure.
Backwards? We'll go backwards. And again, in the problem, it'll say backwards. It'll say a Kc value, less than 1. It'll be very obvious. Okay? So, if we're going this way, do we have any of this then at the beginning? No. Do you guys want to do one where we might have some value? Yeah! Let's say we have 0.2. We might, right? Jennifer, if I give you bread and cheese to make grilled sandwiches, could you make grilled cheese sandwiches? You could. However, is there a possibility I give you a loaf of bread, some cheese, and you make grilled cheese, but you already have a grilled cheese at the beginning? Is that possible? Yeah. So it's possible this already has a concentration. So, what do you want this one to be for concentration? 0. What?
25.
25. Is that what you said? Good. So this one is a little different than yesterday because you have two values at the beginning, and that's cool. Just make sure you know which way it's going. So, things are going to change. That's the C. Is this going to lose or gain if it's going this way? It's going to lose. So it's going to be minus. Do we know that change?
3.
Do we know the value? No. So that's the X part. We don't know it. But what's it going to be magnified by?
3.
3. And again, I'm getting that straight up from this. And again, the change is X because again, we don't know that. And here, we're obviously gaining because we're going this way. And that's the 2X. So Jesse, put it all together for me. What's going to go over here? Plus 2X, absolutely. Erod. This one. Perfect. Love it. And then that's it. So again, we're going to lose this because we're going this way, right? If we're going this way, we're obviously making more of that, which means we have to lose stuff, right? If you make more grilled cheese, you're losing bread and cheese. If you're making a pizza, you're losing the dough, the cheese, the pepperoni. You're gaining pizza, but you're losing those individual parts. And then it's just straight up an equilibrium expression. Okay, for this one, you guys know it's going to be Cl2, and that's going to be a 3. And then AlCl3 is going to be squared. And then you would just plug it in. So the answer for this one is 0.25 minus 3x cubed. That cube stays. And the oops, I don't know why I did that, I apologize. And then the 0.2 plus 2x squared stays. And again, we didn't solve for x, so we don't need to do it. But that's the answer, that's the setup. On the test, there's gonna be two like this. The third one, you have to solve for x. That's the next problem. Now, second hour. You guys are second hour. Third hour. Third hour, somebody noticed something and told everybody, which I thought was cool. I'm going to tell you what they said. Do you notice how this is squared?
Yeah.
Do you see that the 2x goes with the square?
Yeah.
The 3 goes with the cube?
Yeah. Oh no.
The 2x went with the square. The 2x went with the square. The 3x went with the cube. That's kind of correlated. If you end up with a 2x here and you start putting a 4 or something, or not a 2, or not a 3 in this case, I'm sorry, you know something's wrong. That's not a coincidence that it's 2 and then squared. Okay, so kind of go from there. That's something third hour caught. I like it a lot. And that's the answer. Are there any questions?
No, sir.
Seem pretty chill? And again, in this problem, okay, one of you in here asked a really good question. How are we going to know if it's forward or backwards? The problem will tell you. And that's a good thing. Are we ready to solve for x?
Yes.
Hey, buddy. Shout out Moises on YouTube. All right, let's solve for x. Okay, Moises, I just did that. Would you like this guy to go forward or backwards for the reaction? Or do you want me to make it a surprise?
Surprise.
All right, cool. So let's set it up like this. Let's do a problem where I'm just trying to think of something cool off the top of my head. Okay, we'll go Br2, which is a liquid, plus sodium chloride, which is obviously aqueous. Then we'll go to chlorine gas again, and we'll go with sodium bromide, which is straight up aqueous. Balancing this, 1, 2, 2, 1, ICE. Is this our first one we've done with 4 things? Merge! It might be. All right, and I'm going to tell you that the Kc value is 2.112311. 1. So, I'm going to talk to my guy in the back. Does this favor reactants or products?
The products.
The products. So, which way is it going?
Going forward.
Product. Favors products. All right, cool. So, are there things here that don't count? Let's start there. Yeah, the liquid don't count. Is that out? It is out. So, what if I tell you that this reaction is going forward? Let's assume. Do you guys want this to have stuff already or not?
Yeah.
Do you guys want values here?
Yeah.
Because it doesn't matter for the problem. It just, there's numbers. Want to do that?
Yeah.
Okay. Or do you want to do 50-50? One of these is 0, one of them isn't?
No.
Not? Both numbers?
Yeah.
It really doesn't matter.
No.
Okay, we'll do 0.2, now we'll do 0.3 and 0.3. And we'll say this is 0.5. Here's what's going to happen. For you to find x, I would have to give you numbers. And for example, do you guys remember when we were just small little humans and we were doing this kind of?
Yes.
Yeah,
Almost like it was
almost like it was
yesterday.
yesterday, right? And then we started plugging in numbers and stuff? You guys remember this part of it?
Yes.
Yeah. What if I gave you this number? What if I gave you the 0.33?
But you did.
But I didn't yet.
Wait.
So, what if I tell you that at the end, this salt concentration was 0.
Oh, damn.
Oh, where?
4. I can tell you, hey, at equilibrium, the concentration is 0.4.
Oh, wait, the X.
And then we'll just separate it.
It'd be 0.05.
Yes. So, let's set up the rest right now, okay? X's, subtract or adding for this guy.
Subtract.
It's gonna subtract, right? So it's going that way, right?
Yes.
So minus 2x, the 2 comes from here. This is plus x. This is plus 2x. Can we agree on that?
Yep.
Very nice. And guess what? If we did this normally, right? I'm just gonna box this for a second. Wouldn't this be 0.5 minus 2x? Correct, right? But doesn't that equal 0.4 in this case? Can you guys solve for x?
Yeah.
Yeah. It's already been said. X is 0.05. Because 0.1 divided by 2 is 0.05. So,
What about the right side? Can I
Exactly.
3x equals?
so in this case, right, we would have this. 0.3 plus x, correct? Nothing different. 0.3 plus 2x. Again, anything different? No. However, oh,
Are we gonna get the line and all of the problems?
Yes.
It's gonna be random.
yes. Yes, and that's why I'm going to make sure this isn't going to be a crazy long video because I want you to look at the homework that has them today so you can see them. But yes, and in this case, I would give you this as well. I would say the equilibrium concentration is. The initial concentrations are. So you will even know exactly where to put those numbers. So in this problem, you would be given everything I box. For sure. For sure. So, let's talk about this. Do we know what x is now? Can we plug x in then?
Yeah.
Yeah. So this will be 0.35. This will be 0.4 now. Because again, 0.2 times 0.05, sorry, 2 times 0.05 is 0.1. You know, 0.3 plus 0.1 is 0.4. And then, guess what, guys? Remember how, earlier this week we just plugged in numbers? Can we do that now? Yeah. So, in this case, we can do that. Kc is going to be, again, we're going to have the NaBr. That'll be a 2 Cl2 1. Again, getting these numbers from here. This is the NaCl, that is squared. And then we're just plugging in those numbers. So in this case, 0.4 squared, 0.35, 0.4 squared, and that's the problem.
Where'd you get 0.35 and 0.4?
The 3, 5, and 4 here? Wait, because we plugged in x.
Oh, shoot, yeah, you're right.
Yeah, we plugged in the x values here. Good question, good question. So I am trying to find a calculator, just like I know some of you are ahead of me on this one. Where's the M button here? There we go.
We do not.
Yeah. The answer is going to be good. So this reaction, actually, don't these cancel out? I think I said you're gonna have to plug that in. Do these cancel?
Yeah.
Yeah, these cancel. I didn't even have to do that. Why did I do that? 0.35. The reactants are going to be favored in this case. And that's how you would solve a problem for x.